Process of meiosis. First, I want to cover review some things from chapter 6.1. Okay, so somatic cells. These are body cells that makes up most of your body tissues and organs, such as your reproductive systems, spleen, and kidney. And we have the gametes. Gametes. I'm not really sure how you pronounce it, but yeah. These are your ovary and eggs for the female and sperm cells for the male. Each species has a characteristic number of chromosomes per cells. We have 46 chromosomes and we have 23 pairs of them. Um, we have homolo- homologous chromosomes. So we have two chromosomes, right? In one cell, one from mom and one from dad. They are same in length and appearance, same genes, though may differ, and are ordered from largest to smallest. Then we have the autosomes. These are the chromosomes that contains genes for characteristics not directly related to the gender of the organisms. Yeah. Then we have the sex chromosomes. Directed directly controls the development of the sex characteristics. So humans have two chromosomes, X and Y, which determines the gender of the organism. For a female, we must have an XX, and for the male, we have an XY. They are not homologous. So since we have 23, 22 are homologous and one is not. And here we have X is larger than Y, where Y contains the male trait and the smallest, and is the least. We have the diploid cells. Diploid cells are cells that has two copies of each chromosomes. Um, they are more common from in the body cells, and haploid are cells that has only one copy from each chromosome. So in this case, one parent, one mom, one dad, or gametes or gametes. I'm not really sure. So yeah. So going back to 6.2, process of meiosis. Cells grow through two rounds of division in meiosis. Meiosis reduces chromosome numbers and creates genetically diversity. Pairs of homologous chromosomes separate in meiosis 1. Homologous chromosomes are similar but not identical. Similar chromatids divide in meiosis 2. Sister chromatids are copies of the same chromosome. Let's see. Um Going back to 5.3, we can see a chromatid, right? Looking like an X with one chromatid meeting or intersecting with another chromatid in the centromere. Then yeah. Meiosis 1 divides homologous chromosomes into four phases. Okay, so for before meiosis 1, DNA has already been copied. Um, divides two homologous chromosomes, which means two haploid cells with duplicated chromosomes. So that's how it looks like. Ugh. So we. Oh no. So we. Okay. So the prophase 1. Prophase 1 is when nuclear membranes break down, centrosomes and centrioles begin to move. Spindle fiber starts to assemble to um, du- duplicate chromosomes and condenses and homologous chromosomes between begins to pair up. Then we have metaphase 1. Spindle fibers align the homologous chromosomes along the cellular equator. Each side has have chromosomes from both parents. Then we have the anaphase 1. It is paired homologous chromosomes separate from each other and move to opposite sides of the cell. Sister chromatids remain attached. The telophase 1. It is when the spindle fibers disassemble and the cells goes to the cytokinesis. We have meiosis 2. It is divides sister chromatids into four phases. DNA is not replicated between meiosis 1 and meiosis 2. Prophase 2 is when the centrosomes and centrioles move to opposite sides. Spindle fibers also assembles nuclear membranes. Ah, spindle fiber assembles and nuclear membranes break down. Then we have metaphase 2. Spindle fibers align the chromosomes along the cellular equator. Anaphase 2. Sister chromatids are pulled to opposite sides of the cell. Then we have the telophase. Nuclear membranes forms again around the chromosomes. Spindle fibers break apart and cells go under cytokinesis. Meiosis differs from mitosis in significant ways. Meiosis has two divisions, while mitosis has one division. Meiosis, in meiosis, homologous chromosomes pairs in the cellular equators, while in mitosis, homologous chromosomes never pairs. Meiosis results in haploid cells, and mitosis results in diploid cells. Ma- yeah. Haploid cells, yeah. So we have the game gametogenesis, which is the production of gametes or gametes. I'm not really sure. So for the male, you have the sperm, and for the female, you have the eggs, which is the ovary and stuff. So polar bodies, haploid cells produced during meiosis in the female species. These cells have little more than more DNA and eventually disintegrate. Let me get a better definition for that. This way. So here, the other cells produced by meiosis becomes polar bodies. Polar bodies are cells with little more than DNA that are eventually broken down. In many species, including humans, the polar body produced by meiosis 1 do not go under meiosis 2. And that's it. Yeah, thanks, and good luck for your test, guys.